Increasingly, I find it necessary to produce the beginning of a video at the end of the shoot, and that's because I simply don't know where I'm going to get to. However, today in part 3 of making a machinist jack, I'm quite sure this is going to be the final episode. So in this video, all that's really left is to complete the ball joint for the pad on top of one of the screws. So I've got the ball here formed in the last video, and we need to machine this so that this can be pressed on. Now that's far easier said than done. A little more about that later. And of course the other task today is to heat treat the various components. That comprises hardening out and tempering the screws and case hardening the rest of it. Now for producing the ball joint, I need to produce this radius in here. So I've made this form tool from a piece of silver steel or drill rod, and it's been machined so that we've got the necessary clearances. The first thing I did was to produce the radius on the end there, and that was done using the radius turning tool. And then I milled it along the center line. I provided the clearance on the rear side here, and also importantly clearance underneath, just leaving a very small land which you may be able to see around the edge there. So we'll see how that goes. I'm going to machine the hole to this diameter and then plunge this in, and then the hole itself will provide support on the rear of the tool to resist cutting forces on this tip here. Now rather than going straight into machining the underside of the actual pad, I'm going to make 1 or 2 dummy pads to make sure that I can get this internal radius correct in here, and also the crimping which is required to press this onto the ball. I've done some design work here, and I think that 6 cuts, not quite up to the center line of the radius, will give me the right degree of crimp, but we'll come back to that later. Okay, I'm forming the radius, this radius here. Now I'd originally dimensioned that as 0.25, 6,37, but that's just a bit too big, and I've reduced it to 5/32. I'm not using the radius turning tool because this is one of the operations I couldn't successfully complete without changing the design of the tool holder. So I've just made a form tool. It's quite a big cut really for my small lathe, so I'm going to have to go carefully. You can hear a bit of chatter there. I've just lowered the tool. I think it may have been slightly too high, so it may have been rubbing, and seems to have got a better result now. So with a bit of judicial use of the cross slide and top slide, I've been able to get a 1/4 inch radius in there. So I think I'll settle with that. This of course is just the test piece. Now we'll continue and start machining the ball joint. Okay, our form tool fits in there. I might just try and remove a little extra material from the side there, so that from the inside, so that this can go a little bit further before it starts cutting, and then it can back up against that face there just to provide a bit of support. So I've mounted the tool in my tailstock chuck, and we'll see if we can form this internal radius. I have to admit it's the first time I've done this, so we'll see how this goes. Slow down a bit. I think plenty of coolant is going to be necessary. So I've increased the clearance on the land, on the grindstone, and just touched up with an oil stone. That's one change. Hopefully that will help it to cut a little better. The other thing I'm going to do is to drill out the center of the hole, just so that we don't have to work against a part of the tool that's not going to cut very well. So I just remove some center material there. It won't make much difference to the efficiency of the joint, but hopefully it will enable me to plunge in better. We've got to go another 60 thou deeper, 1.5 millimeters, and clearly to do that I'm going to have to relieve the center. So we're going to drill that out again, another 1.5 millimeters, and then plunge again. Finally, we need to put a slight taper on the inside, and we'll just chamfer the outside as well. Okay, time to part this off. Well, we've got two pads now, the real one with the other side not yet formed, and the dummy one. Now I'm going to work on the dummy one now by mounting this on an arbour using some glue, and then I can mill the 6 slots on the other side. Once I know that I can press this on, then I'll work on the real one. So I'm going to use the same piece of steel and just make a little registering diameter so this can sit in there, and then we can glue that in and make sure it's concentric. So here are the slots. What I'm going to do now is to remove this from the arbour and at the same time do some case hardening. So what I found is that this adhesive releases when I get to sort of a blue heat, and I'm going to use the heat that's in the component to case harden at the same time, rather than sort of cool everything down and clean up. Just do it all in one go. So we're getting ready now to do this test crimp onto the test ball that I made. Now, I did my best to not actually case harden these tabs, so you probably couldn't see, but I immersed the component in the compound from the top, but there's a little bit of hardness there. I tested it with a file. Now, I know that the case hardening is only very thin, but I still don't want to risk any cracking. So what I'm going to do is just anneal these tabs, and hopefully that won't affect the case hardening and the body of this component. Again, this is just the test component. The real thing we'll do later. So at last we're ready to try the crimping operation. Now, you probably notice here that the ball is a little bit sloppy in there as compared with the real one, which is a nice fit. But nevertheless, hopefully this will prove that this process works. Now, I'm hoping that the tabs are soft enough to deflect without cracking. Now, I've come up with a drawing for a die, and the die consists of a body with the elements of the die which are split for assembly, and you'll see that in a minute. The bolt or the screw sits in the middle, and the pad is on top. So here are the components. This is the body, and the die has to be split for assembly, so it goes over the outside like that. It happens to be a nice fit on the square there, and also this is a nice fit into the body, so it should keep everything central. So we just assemble it. It's a little bit tight. Now this is also case hardened, the split part of the die, and the reason I did that was because I wanted the tabs to slide over the top of the case hardened material. I thought that might be a better option than a soft material where it might just dig in. So that's assembled now, and then the work goes over the top like that, and then we can try pressing it in. Now, according to the drawing, we should have something like 40 thou or 1 millimeter of downward movement on here to deform the tabs around the ball. Now, what might not be clear in this is that surface there is tapered. So it's a tapered surface here, and the tabs are being pushed into the taper and round the back of the ball. So it's all quite small and very specific to this job, but I thought this would be an interesting process to see if I can master it, and maybe it will come in useful somewhere else. Well, it's time to give this a go. Instead of the real one, we're going to use the test piece. I've just modified the lower end of it to simulate the screw thread, which drops in the hole there like that. That's it, that's in. Now we're going to need to make sure that the bolt or the screw is pushed upwards like that, so that this can be crimped over the top. I put a bit of oil on there just to reduce friction. Let's go and take this over to the press and give it a go. Okay, after a little bit of fiddling around to make sure everything is lined up, we can just make sure that that's right, the pin's pushed up there, and then we can see what happens. But it's certainly gripped it nicely. I suppose the question is, how strong is it? It was very easy to press that. Let's have a closer look at this. It's certainly made a sound joint, I would say. There's something there not quite symmetrical because it's slightly binding in one direction, but the degree of movement is fine. I'm quite happy with that. The other thing I notice is that the splits have compressed together, as you can see there. Now that's because that ball was slightly undersized. Now the real one is slightly bigger, and I suspect on that one that it will fully grip the ball before it comes together. And of course the danger there is that I might end up crimping it too far and then having to back it off somehow, and I don't know how I can do that. So with the real one I'm going to have to be a bit more careful, but I'm happy with that. I think that's done a good job. There's no signs of cracking, and I think it's quite strong enough. That's what I was hoping for. Okay, what I'm going to do now is work on the real pad. So I'm not going to show that. It's the same process as I used for this one, and when we get to that stage I will continue with the heat treatment, so the case hardening and the hardening and tempering of the screws. Off camera I've case hardened the mild steel components. That's the two spacers, the base and the lock screw. Took quite a long time to clean them up to get the scale off, but yeah, they've come up quite nicely. I've also hardened and tempered the two screws, so they're complete, and made a little Tommy bar. That's just 1/8 silver steel, and also completed the pad, the real pad. That took a lot longer than I anticipated because I had problems gluing that onto my arbour. Initially I was just relying on the face, and of course with the serrations there, the glue I don't think was curing properly, so then I had to make it so it gripped on the outside as well. First time that failed too, and then I did it again and finally succeeded. Now the other change I've made is to increase the wall thickness here, so effectively the tabs are 25% thicker than the original ones. Doesn't sound like a lot, but when you compare visually the two, it suddenly looks a lot thicker. So I have annealed the tabs, well, not annealed, I guess tempered tempered the tabs as I did last time, but I'm still a bit concerned that with the thicker wall thickness, you know, maybe they're not going to bend as easily as the test one. But I just wanted to see if I could get a stronger crimping action around the other side of the ball. Anyway, we will assemble this, and hopefully this will be the last operation. Okay, and as before, I'm going to put a bit of oil around there, and let's see if we can press this on. So here's the completed ball and socket joint. That pressed together very nicely. The result is really good actually. There's hardly any play in there whatsoever. It was definitely the right move to increase the wall thickness of that cylinder, which was then slit to make the tabs. So that 25% extra thickness on the tabs was definitely the right way to go as compared with the test piece. And I'll include those dimensions on the finished drawings if anybody is interested. The other thing I would say is that yeah, this is ideal. This is for me a new process that I've mastered, and I'm really pleased with that joint. The degree of rotation and the smoothness of it is just what I wanted. Now you may be wondering why this isn't discoloured as compared with the original, or as compared with the test piece. The reason for that is I tempered the tabs with this sitting on top of a fire brick, whereas in this case I sat it on top of this piece of steel, and that took the heat away and just kept it focused on the tabs before quenching out. So that was something else I learned. That concludes this mini-series on making a machinist jack. Now along the way I've learned several things. The first is that if you're case hardening bright drawn mild steel, as long as you keep things symmetrical, the amount of distortion is negligible. I really appreciated this little radius turning tool, and it's come in very useful already. The third is that simple press operations using an arbor press can be successful, and you can even get it right first time if you plan and draw things out beforehand. And finally, making test pieces is sometimes the way to go, and that little test piece, that crimping operation, was invaluable for getting the final product right. Thank you for joining me. As always, comments and questions are welcome.